This will be the very speedy pre-calc review. You use this formula for exponential growth and decay. A is how much you start with. If your rate were, let's say, 3%, if it said growth, you would put 1.03 in for B. If it said decay, you would put 0.97 in for B. If the problem happens to be a half-life problem, then this number right here gets a little bit weird and becomes the number of half times till you have a half-life over x. If the problem asks you to find the exponential function, you need to write out the y equals a times b to the x equation twice. After that, you're going to substitute each number in for x and solve by substitution. This would be 2 equals a times b to the 1, and this would be 8 equals a times b squared. Pick either equation, it doesn't matter which, and solve it. The red equation becomes 2 over a equals b, and then substitute that in for b in the other equation. A little bit of dealing with fractions, and you end up with 8 equals 4 over a, and so a is equal to 1/2. Go back to your original equation, put in a, and you've got it. The answer to this problem would be y equals 4, let's see, hold on, 1/2 times 4 to the x power. You also have to know all about logs. Most importantly, how to go back and forth between a log and an exponent. So if you're faced with something like this, log base 2 of 8 equals y, you can translate that into 2 to what power equals 8. And most of the time you're going to want to do these in your head, but I'll show you how to do a more complicated one right here. More complicated problems, you're going to rewrite them so they have the same powers. You need to look at the 1/4 and say to yourself, oh, that's 2 to the negative 2 power times 2x minus 1. And then take a look at the 8 and go, oh, well, that's 2 to the negative 3. And now what you have is what I probably shouldn't have called a matchy-matchy question. This part right here, because the bases are the same, are actually equal. And if you solve that, you get negative 4x plus 2 equals negative 3. Work it all out, and you get 5/4. You will have to know how to deal with all basic types of log problems. The big idea in all of them is to isolate the log first, but there's different types. In this problem right here, you're going to add 1 to both sides to isolate the log. Then you must decide, do you want to think about this as a converting problem or think about it as exponentiating each side? If you think about converting it, you need to know that base is e. This is e to the 6th power is equal to x. When you see a problem with matching logs on both sides, like this problem right here, it has a log, those two logs have the same base. That means the insides must be the same, so you can just jump to x is equal to 2 and pull it out. So log on one side, like this problem, you have to convert it. Log on both sides, like this problem, you can do the matchy-matchy thing. This problem, we subtract 3 to isolate, then we convert. You need to be able to deal with your calculator. If you convert this, this is log base e of 5 equals negative x. You need to know that to type this into your calculator, you type in ln 5. And then divide both sides by negative 1. And in a problem like this is just purely a calculator problem. You need to know that on the graphing calculator, it types in like this, log of 18 divided by a log of 12. That's a change of base rule. That's definitely going to be on your test. You need to be able to deal with making a basic log graph, which you do by taking the log and rewriting it as 2 to the y power equals x, and making a table of values where the y values are substituted in. Y to the 1 is, 2 to the 1 is 2, 2 to the 0 is 1. That's this graph. if you have this negative right here in front of the log, that's going to flip it upside down. If you were to have a negative inside the log, that's going to flip it over the y-axis like this. And if you have a graph that has an x minus 3 on the inside, you're going to ask yourself what makes that equal to 0. That's positive 3. So this graph here is shifted to the right 3. And it would take the black graph and move everything over 1, 2, 3. Most important thing to be careful about for these graphs is that you indicate where the asymptote is since it was shifted, and don't just sort of wander across it. You have to know how to both expand and condense, and so you need to know that addition becomes multiplication rule. This would be log of 10, which is actually 1, plus log of x, plus 5 log y. The most common mistake students make in these problems is notice only the 5. The 5 is only the y is to the 5th power, so the 5 only goes in front of the log y, it doesn't go in front of the other ones. And on the next one, you need to take the 1/2 up. This tends to be confusing. Sometimes people forget that x to the 1/2 power is really the square root of x. So this is log of the square root of x over y. It's the subtraction becomes division rule. I think everybody should be fine with the finance problems, but let's say you wanted to double your money and you had a 7% interest rate, and you need to know how long it would take to do that. And you're going to compound monthly. You would start off by filling all the numbers into the equation. Since you're doubling your money, the amount is twice of what you started. And the rate is 0.07, and it's monthly, so k is 12, and this is to the 12t power. So what you have to do is solve something that has an exponent as the variable. And really, you could just think of this as log with a base of 1 plus 0.07 over 12 of 2 equals 12t. And as long as you can type this into the calculator, you're golden. If you don't know how to type that in, you would type it in as log of 2 divided by log of 1 plus 0.07 over 12. You will still need to divide the whole thing by 12, by this 12 at the end to get t, but that should be pretty easy. That's it. Study your old quizzes and the test will be a piece of cake. Good luck.